Yeah. Okay. Hi, everyone. Thanks for coming back. Hope you had a nice coffee break. So now we have another keynote talk. This one is by Saadia Gabriel. She's a assistant professor at UCLA, working in NLP and machine learning. She leads the Misinformation, AI, and Responsible Society lab, which focuses on understanding and mitigating threat of false information through AI systems. Her talk today is on emergent behaviors in multi-data systems. So, Saadia, please. Thanks.
Hi, everyone, and thank you for the introduction. So just to start off with some motivation, then we've seen this growing phenomena of online information diffusion where increasingly people are turning to online platforms to share information and to get their news. Social media platforms are becoming one of the main sources of news right now. And that's led to the spread of narratives that can shape not only these digital environments, but also physical environments offline, referred to by Nobel Prize winning economist Robert Shiller as the contagion of narratives, where we see these stories driving major world events and shifting people's opinions. So some of the positive effects of this online information diffusion include that now more than ever, then we have open information accessibility, for example, to medical information. However, there are also negative social effects that can arise, like spread of misinformation, in particular due to information overload, where people are exposed to so much mixed content that they find it hard to discern between what is the truth and what is fiction. As highlighted by this figure here, we can see that information sharing behavior is not necessarily positively correlated with the quality of that information. For example, in 2020, a Pew Research poll found that a quarter of surveyed Americans believed it was probable that the COVID-19 outbreak was planned by people in power. So we see this giving rise to these mass conspiracy theories and greater spread of potentially harmful narratives. There are also internet manipulators who take advantage of these platforms to try to spread their particular agenda and shift public opinion. And this is happening even before we had LLMs. So this is something that's completely independent of what we're now facing with this AI era and the scalability of influence operations, where we see effects of more primitive bot influence operations going all the way back to 2016, where it was highlighted that internet influencers from outside of the US were trying to influence social movements, legitimate social movements inside the US, like the Black Lives Matter movement. And this figure here was showing that they were actually pretending to be members of this movement on both sides of the political spectrum. So here we see accounts that were involved in the online discourse around the social movement, where the orange shows the accounts that are associated with this particular influence operation. So that was back in 2016, but now that we have large language models, the same thing is going on, but now there are new tools that give them greater capabilities to scale these influence operations. In particular, a number of studies recently have highlighted the persuasiveness of language models, including an Anthropic study looking into how can this shift people's beliefs where there aren't strongly entrenched priors, as well as a Nature study that was looking into how GPT-3 can actually convince people through personalized ads to spend more money on products. So this is particularly concerning because we have cases where there's information asymmetry between the LLMs and the users. So the users may be persuaded through LLM arguments to believe those arguments, even though that they don't have the pre-existing knowledge and skills to actually discern whether or not the argument is reliable. This is not only a speculative risk, this is something that we've already witnessed happening. So back in 2024, OpenAI disclosed that they'd uncovered some cases of influence operations misusing their platform. In particular, they found 5 different covert operations that were using their models to generate multilingual content and then spreading that across various social media platforms. So luckily, they were able to disrupt this before it reached critical mass. For example, they found one operation called Doppelganger that was posting on X and other platforms. But this is an increasing concern going into the future where these operations might become cleverer and cleverer at hiding from detection. So how do we actually evaluate for this? How do we detect these kind of risks before they happen? That's what I'll be discussing in the rest of this talk. So I'm really interested in the role that social simulation can play in a dual evaluation of both negative persuasive capabilities of LLMs and positive capabilities. And so my research group, Misinformation, AI, and Responsible Society Lab, has been doing some work around how do we intervene against misinformation? How can we ensure scalable oversight of these increasingly persuasive LLMs where we cannot easily find a large pool of evaluators who have the skills to determine if these arguments are reliable or not? How do we evaluate if the interventions we're coming up with are robust in different kinds of settings and across different domains? And how do we model intent and consequences of language and know how predict a particular generation, for example, is going to affect the user and perhaps shape society? I'll be highlighting 2 recent works led by my students that look into this modeling of intent and consequences as well as the scalable oversight angle. And I'll give a quick introduction to scalable oversight for anybody who's unfamiliar with this, where you can think of it in terms of this scenario where we have a human who doesn't know how to code, and we have a very capable AI agent who they're then asking to provide them with a fast sorting algorithm. So in this kind of scenario, we have this information asymmetry where the AI knows a lot more about coding, and the human can't really tell if the solution that's been provided to them is accurate or not. But we still need some way of determining if this is a viable solution. So the first project I'm going to talk about touches upon this. This is some work where we're looking into how can we use multi-agent debate to assess the truthfulness of controversial claims. It will appear later this year at NeurIPS. It was led by a large team of incredible collaborators, but in particular, my student Solomon. So debate has been proposed as a zero-sum game where we have 2 different agents who are assigned to different sides of an argument. And over different rounds of this debate, then they can provide statements that either refute the other agent's argument or supports their own argument, as well as in answering queries from the other agent and a judge who ultimately decides after the rounds of this debate who came up with the most convincing argument. A simplified version of this is consultancy. So here we're going to think about this single interaction between a consultant agent and the judge, where they try to convince them of a particular point. And for this work, we focused on public health claims around the topic of COVID-19, given the significant consequences to the general public of these claims. and considered different human judges who had varying levels of cognitive bias. So we wanted to see how do these interactions help when we have judges who have a strong prior to believe in COVID-19 conspiracies and anti-vaccine narratives, for example, versus people who have more moderate beliefs or beliefs that are more in line with the scientific mainstream. So here we have a scale in terms of the judge's belief, and we look at which argument they think is likely to be true, as well as their confidence in this judgment. And so here we can see some results for the protocol effectiveness when we compare between these debate interactions and the consultancy interactions. So we can see in all of the cases of prior strength, when the judge has low prior strength to a strong prior strength, then debate was deemed the most effective protocol, really highlighting the need for this contrastive interaction to be able to make these judgments. And in particular, we look into the updating behavior of their beliefs. So we see more often than there's harmful updates for the consultancy setting. So they're still being swayed in the consultancy setting, but we see some cases where it's actually shifting their beliefs to be incorrect. And more cases of the beneficial updates in the debate setting. We also look at different settings for the judge where they're exposed to varying levels of information, for the debaters where they're exposed to varying levels of information about the judge. So here we first start off with a human judge, and then we look at what if we have an LLM agent that has been personalized based on the information we had about these judges. So for the public persona, then the debaters know what was the persona of the judge, so they have information about the belief prior. For the private persona, then the debaters don't know. And then we also look at some settings where the judge was non-personalized. So we see here, again, debate winning out. But in particular, I want to highlight that the persona-based LLM judges actually outperformed the human judges in terms of accuracy at this task. So this is an indication of how this kind of debate simulation might work for evaluating truthfulness. So this is a very promising findings, but also alarming when we think about the dual use case. So what we found here is that we are seeing this persuasion effect from the LLMs, which could be really concerning if we have cases of failed LLM consultants on social media, for example, who are specifically instructed to sway people's beliefs. In particular, because we already know that humans struggle at misinformation detection, sometimes more than LLMs, as highlighted by our judge results. So how do we develop robust interventions against this type of negative persuasion in an ethical manner? And that's where I want to shift to thinking about building these large-scale social simulations where we can actually model network behavior and test different kinds of counterfactual scenarios with various interventions to see how do they affect collective behavior and what would be most effective in terms of making users robust to manipulation online. So this is the next work I'm going to talk about, Mosaic, where we look at modeling social AI for content dissemination and regulation in multi-agent simulations to appear at AIM and LP, and this is led by my student Ganglin. So this builds on a lot of prior work looking at game theoretic approaches to modeling misinformation diffusion, so-called persuasion games, as well as even going back before that, work that was looking at how can we do multi-agent simulations of social phenomena, for example, net logo. And is motivated at looking at how can we best protect users online using these kind of simulation evaluations to predict what the risks are going to be on these platforms and then come up with interventions against them. So even before we had this popularization of the term frontier AI and the release of ChatGPT, then we saw that there was some interest in this with early social simulations. I'm quoting from this paper back in 2022, where they ran a study looking at designers inside of marginalized groups and were showing that they could use this kind of social simulation to help them identify the types of harassment that might arise in their designs that would target vulnerable populations and come up with ways of mitigating that. And now we have even more powerful AI. So it seems like we should be able to build better simulations today. So, oh, don't know where that went. Oh, yes, I don't think that's the right one. Oh, here it is. Okay, so this has been explored in thinking about in-person social interactions. For example, there's been work out of both Stanford and CMU looking at how can we understand the limitations and capabilities of AI for social intelligence in mimicking these kind of social interactions and the way that they form relationships and activities in social simulations. Here, we want to move from these simulations of in-person interactions to these online spaces where we would expect to have direct interaction between these human users and LLMs. And so simulation for generating data about the world has been used for a long time and before in reinforcement learning. There's this idea of world models and that we can build these simulated environments and sample from them to then train our system. And we're thinking about a similar kind of paradigm here, where we want to first build this system for mimicking these social interactions, and then use that to run many different instances and generate data that will help us understand how different interventions help in various scenarios. So for that, we're going to have a directed graph that represents our social network, and we can have different nodes that represent diverse users within our graph. We'll have interactions between these users where we can see how do they transmit information to each other, as shown here, where we can see them sharing different kinds of posts, as well as interacting with the posts through liking or flagging those posts. So there's various ways in which we can use this. First way is we can think about this as a mechanism for modeling user representations. So seeing how effective different kinds of user representations we develop are by looking at how does that affect the fidelity of our overall system based on what we know from the social sciences about collective behavior. We can think about this in terms of population behavior simulation as well. For example, we want to predict what factors might lead to a flash crash. We can think about this as a means of predicting content diffusion. So if we want to see what kind of content is more or less likely to be engaged with, as well as misinformation intervention. So seeing how different kinds of governance policies actually affect the dynamics within our simulated social network. So for the mosaic simulation that we have, then we have our graph where we have our user nodes, and then the edges are defining the relationships between those user nodes. So who's following who? And then we propagate different kinds of information through our social networks. So we had a partnership with journalistic organization called NewsGuard, where we had access to what are current misinformation narratives that are being spread online. And we can disseminate these through our simulated platform and then see what are the behaviors interacting with that. How does that match up with the behaviors we actually see in the real world? We also have various other mechanisms for data management that help with the fidelity of our network. So something that's really important is the memory mechanism to keep track of the agent histories. And I'll go into a little bit more detail about that in a bit. But just highlighting the kind of information that we can infuse into this network, then we're taking news reliability labels that we can use in simulating different kinds of content moderation settings, as well as the narratives themselves that we know are actually real misinformation narratives that people are being exposed to right now. To assess if our simulation is realistic, then we can compare against what's already known about social networks. So there's certain patterns that we know exist in these social networks, like homophily is something that's been highlighted in the social sciences, where we see that users like to cluster together with users who are similar to them. We also see this power law distribution pattern where there's certain users who are influencers within the social network, and triadic closure where we'll see that friends of friends tend to then become friends themselves. So we end up with these loops within the network. So here we can see some of the interactions going on in this simulation, where these different agents are sending messages to each other and posting. And these agents are actually instantiated using these really detailed, fine-grained profiles of users. So we interviewed users that we recruited on this online crowdsourcing platform. We asked them a number of different questions, like age and gender, value systems, what would they do with $1 million, those types of questions. And we use that to create our agents. And so here we can actually see how do they interact with the news. So we create a version of content moderation similar to what you would actually see on a social media platform. So community notes is something that's been widely adopted now. X uses it. Facebook has moved to using it, where it's driven by the communities themselves. Users flag posts and add some context for why these posts might be reliable or not. And so we have the same kind of system replicated within our simulation. This is the dynamic memory updating. So here we can see when we have these kind of agent interactions, we can keep track of what was the history of that agent. So we keep track of their actual interactions, like whose post did they comment on, but we also keep track of their reflections. So here the agents are providing some reasoning for why did they take certain actions. Now I'll go into some of the ways in which we ensure fidelity of the social network. So a big part of it is the representations of the users themselves. This is really critical to having good simulation. And so having this very detailed personas so very helps in ensuring fidelity. We also look at their engagement behavior and how does that match to what we would expect. And so here we see when we look at these different kinds of engagements like reposts, likes, and comments that it follows a power law even when we're randomly initializing the user personas in the network graph. We also did a comparison between the behaviors of the human users and the behaviors of the LLM agents that are representing them. So we showed the human users and the agents the exact same social media feed and asked them to interact with these posts in various ways, like liking and sharing or commenting. And then we see how does that compare, and we find that there aren't statistically significant differences for most of these engagement types in the behavior between the human and the agent. So it seems like we do see high fidelity in terms of the ability of these generative agents to mimic individual engagement behaviors. However, I do want to highlight this is not universally true. So we see that the agents model marginalized demographic groups less accurately. And this is particularly important to highlight given that there has been work concerned with how this use of LLMs as judges and this use of LLMs in simulations can actually misportray identity groups. So I don't see this as an intrinsic problem to simulation itself, but more as an open question for future work of how do we make these representations stronger so that they're better able to represent groups that are missing from the existing data and from the development of current user representations. So where else can we see areas for improvement of simulation? We ran this case study looking at the content moderation setting and seeing how does that work in the simulation versus what we would expect in the real world. So here we had different kinds of content moderation policies, one being third-party fact-checking, where we have a fact-checking agent that comes in and then labels everything as false or true. A hybrid approach where we have some mix of third-party and community notes, and then one where we just have a community notes type approach. And we see that content moderation consistently improved both fact-checking and engagement. If you want to see the details of this, because we tried many different settings across various models, DeepSeek, Claude, GPT-4, then you could take a look at the paper. But the main point I want to highlight here is that while these results were really promising in terms of showing the hybrid approach being effective at content moderation, it's not exactly what we would be expecting if it was in line with the behavior we've observed in the real world. So one really important finding is that false news does not spread faster than real news with simulation agents. However, we have evidence that false news actually travels faster with humans. So this is indicating that these agents are actually more cautious than humans in terms of spreading misinformation, which kind of makes sense if we think about the safety tuning that they've gone through. And it's slightly ironic, maybe, that the safety tuning has led to less effective simulations. But I think that's something we need to keep in mind when we're thinking about building these kind of evaluations and trying to relate that to people's actual behavior. We also took a look at the reasoning traces. So when thinking back to the agent histories, where we saw these reflections, we wanted to see if those really were explaining the engagement behaviors of the agents. And we found some discrepancies between the traces and their interactions. For example, they were providing positive sentiment reasoning over 13% of the time for flagging posts, and we would expect it to be negative because they're flagging it, it should be something that's harmful or misinformation. So that's another indicator that maybe there's some issues in terms of the transparency of these agents, and are they actually revealing their real thinking. So the point I want to end on here is that I think that social simulation is going to be critical for evaluation going into the future, but we really need stronger user representations to make it work. We have to think about not necessarily using LLMs out of the box, but we need specialized models that are able to represent a diverse number of users that's actually reflective of the complexity of these online platforms, and have more human-like behaviors. But given that, I think that this could lead to efficient alternative to the kind of piggyback prototyping that's been done in the past, where we can scalably evaluate different kinds of hybrid bottom-up and top-down content moderation solutions without actually exposing end users to harmful content. So I want to thank you all, and let me know if you have any questions.
Thanks so much, Saadia. So, questions? Yes.
Hey, thanks for the talk. I'm wondering, there's the 1 billion personas data set. Have you heard of this?
Yes.
Do you think I see some correlates there for getting more kind of realistic users? Have you tried that? What do you think about that?
Yeah, so we took a look at some of the other works. A lot of it was using synthetic personas, the larger data sets. So I think that's still an issue because we're assuming that those synthetic personas are really going to reflect actual users, and that might not be the case. For example, when I was talking about underrepresented users, we already know that LLMs do not portray them well, so we want real data about those users. We have, I know that in the most recent work from Park, then they had to do some interviews with actual people. And so we've been planning to work with some of their data.
Hi, thanks for the talk. It makes sense that LLMs wouldn't be able to represent underrepresented groups very well in social simulations, but I was curious if there's any work that quantifies like how, or maybe like where specifically LLMs don't do a good job of representing underrepresented groups. Like, what does that look like?
Right. Yes. So there hasn't been so much work looking at that in simulation. I think that would be a really interesting direction for future work when we're thinking about how does that actually show up in these multi-agent interactions. It's mostly looking at what are the behaviors when you're considering a single agent. And so then you see kind of stereotypes in the reflections that you might get. And they refer to it as sort of like a flattening of behavior where it seems like it's not very nuanced. Like if it's it's defaulting to stereotypes basically. So I think that that's the main problem we would need to fix there. And since we've seen from the study that we ran that we can get close to the individualistic patterns with fine-grained survey data, I believe that if we just target that particular gap, then we could have much more effective agents. But I think part of the problem is that it's been overlooked in a lot of the simulation work. There hasn't been much focus on it before. So I think we need to focus more on that problem.
So I think you touched on it several times in your talk, but there are the current generation of, well, like the best LLMs that we have access to today don't do a good job of modeling all kinds of personas that you might ask them to model. But clearly there's a larger infinite set personas that you actually don't want those models to be able to simulate well because of the risks that that would entail. And I think some of your work sort of relies on being able to model, let's say, not necessarily nefarious personas, but personas that are simulating bad actors.
Right.
I'm just wondering, I guess it's similar to the gain of function, the ethics around gain of function research in biology, where it's like sort of it's a quagmire of like, what are the ethics around this? And so what are your general thoughts on that? And do you see a path forward?
Yeah, I think that's an excellent point. I think that if this is really going to be effective at determining risks, then you have to model those undesirable behaviors. But it's a question of what do you actually release. So might be it might be a case of, individual researchers will, in their simulation, they'll have these user representations that or industry research labs that model those particular users, and then you're able to see what would actually happen if this product or tool is manipulated in that setting. But it's not something that you then post on Hugging Face and let other people play around with. So it's complicated ethically, but I like to think that by developing this, and we'll actually get better at mitigating it.